Welcome back, and welcome to Code Once and Share. My name is Ulnar Ismail. I'm an evangelist with Microsoft, and I'm going to be taking you through some best practices on how we can write once and share code across Windows 8 and Windows Phone 8 applications. So to go over the agenda, I'm going to start with showing you a real-world example. And the point of this is to kind of show you that you're going to be learning about patterns and practices and a lot of theory and seeing some really simple examples. But in the end, I want you to see a real-world example that was built by the Huffington Post using a partner that I partnered with in Canada called Halogen Mobile. And I worked closely with them to kind of implement these patterns and practices to build this real-world production-ready application. Then we're going to go over the motivations and benefits. It should be pretty straightforward in terms of what they are, but we want to level set and make sure we're all on the same page. I'll talk about API convergence and the story around that and how certain APIs are available and how certain APIs are not available, and the tips and tricks you can use to kind of make sure your code is portable and reusable. And then finally, I'll actually get into a real demo, my trivial samples that kind of showcase the concepts, and I'll show you how you can use MVVM and PCL together to create portable code. And I'll also go ahead and define what MVVM is and what PCL is, so don't worry about that either. So let's start with the real-world example. I'm going to show you the Huffington Post app on Windows 8 first, and then I'll switch to the Windows Phone. So here we have the Huffington Post on Windows 8, and we'll give it a second to load up. And as you can see, it's a pretty Windows 8 driven. It is a Windows 8 driven application. It's got that Windows 8 UI, so I'm able to scroll through all the different sections. I'm able to pinch and zoom and use semantic zoom. I'll do that one more time. I can dive into education. You can see that I'm able to read that content, go through a photo album. Now let's try and pick another one here. There we go, a little bit better for an article there. And I can invoke the app bar and change certain settings. So that's the app on Windows 8. It's also got the live tile that you can see here. Not the greatest headline there, vasectomies, but that's all right. And so now I'm going to show you the app on the Windows Phone. So this is the Huffington Post app on the Windows Phone. And as you can see, the UI is a little bit different. Obviously, we want to leverage the form factor. The phone's a little bit smaller. The device is a little bit smaller. But you can see the same type of topics at the top there. I'm able to dive into top stories or popular stories. I'm able to pull up individual articles and scroll through them. So, of course, the point here is to show you that you can reuse code. But the great thing here is that working with Halogen Mobile, who built this application, they were actually able to port their Windows 8 application to a Windows Phone 8 application by only writing 18% net new code. So that really shows you the power of what's possible when you architecture your application the right way the first time and then port it over to the other platforms. So let's jump back to the slides. So let's talk about motivations and benefits. Really, the reason for sharing code is to avoid having fractured code, avoiding bugs. Basically, you want to be able to write pieces of your code that you can reuse. Let's say you write an algorithm once to pull up articles. You want to make sure that you can reuse that. You don't want to have to recode it and, again, introduce more complexities or more issues. You also want to make sure that, another benefit is that by doing that, you're actually able to reuse more of your code and you're actually able to accelerate your app development. So if you're a hobbyist, that means you're able to get your app on 2 platforms, really in the time it takes you to get you on 1 platform. Or let's say you were doing some work for a client, you can really pass those savings on to your client. Or if you've got some business savvy, or you're like me, you can actually just pocket those savings and charge the client the same thing. So let's talk about API convergence. And before we dive into this, I want to kind of make sure we kind of scope this talk down to what type of code we're sharing. We're talking about sharing XAML and C# that we use to write a Windows 8 application, and then porting that code to a Windows Phone 8 application. So if you're not familiar with building apps for Windows 8, we've kind of changed the programming model a little bit for Windows 8 in that we've introduced a new set of APIs called the Windows Runtime APIs. Now these APIs are the best of breed APIs that Microsoft has to offer. Everything from the graphic stack to the input stack to networking and using accelerometers or proximity devices, GPS. We've kind of bundled all these APIs under the umbrella of the Windows runtime. And that's what you use to build Windows 8 applications. When you combine that with using XAML, which is your front-end UI language, and C#, which you use just as you would normally code against the .NET API set, you've got a really powerful platform that really, the message here is that Windows 8 is the platform. All those APIs are baked in. There's no need to install third-party SDKs or anything like that. You can build some great apps out of the box. So when you're building for the Windows Phone, things are similar but different. And the key message here is that we're on a path to convergence for Windows 8 and Windows Phone 8 applications, but we're not there yet. And what I mean by that is that we don't have every API that exists in the Windows runtime in the Windows 8 phone runtime. And that can be a bit confusing. So let's kind of go over the history of how you build a Windows Phone application. So if we kind of jump back to the world of Windows Phone 7, if you remember, you were able to use something called Silverlight for Windows Phone. And that was basically a subset of Silverlight that was targeted to the phone. So you still had XAML and you still had C#, but you leveraged your .NET APIs. And that's how you build apps for Windows Phone 7. Moving forward to Windows Phone 8, you still have that same set of APIs, the .NET APIs, and you use XAML. So nothing there has changed. But we introduced the Windows Phone runtime. And that allows you to basically use, again, a set of built-in APIs that take advantage of what's in box. So again, using things like the GPS, the accelerometer. And so that's another set of APIs that you can leverage to code these modern applications. And finally, for completeness, we also have the DirectX APIs, the low-level graphic and audio APIs that you can target using C++. And that's kind of the stack for Windows Phone 8. Now this slide kind of gives you a high-level overview of all the APIs available and what you can do with the Windows 8 developer platform. On the left, you see you have your .NET APIs that you can target using C# and VB. And you can do things like the calendar, wallet, live tiles. In the middle, you have your Windows Phone runtime APIs. Those allow you to access things like geolocation, sensors, and touch. And then you've got your low-level APIs that you can target with C++, and that's your Direct3D, your low-level graphics and audio devices. Now, one of the things you've probably heard us kind of stress is that the core kernel on Windows 8 and Windows Phone 8 is the same. And that's where we talk about the convergence. So we're converging from the bottom up. And ideally, the end goal is to be able to say, hey, whenever you write any program on Windows 8 that runs on Windows Phone 8 without any changes. But right now, we're not there. We're on the path to convergence, but we're not there just yet. So what does that mean for you and how you kind of code these applications? Well, in this Venn diagram, you kind of see that we have a ton of Windows runtime applications. And again, it can get confusing with all these different naming conventions. So let me stress this one more time. When you're building a Windows 8 store application, you're using the Windows runtime APIs. And you can see here we've got a ton of them. When you're building a Windows Phone 8 application, we have the Windows Phone runtime APIs. And you can see there we haven't got as many, but there's still a good set. And in the middle there's this intersect where you have a bunch of the Windows runtime APIs that are also in the Windows Phone runtime. So let's see what those are. So those are the networking APIs, the sensors, location, file system. These are some of the APIs that you're able to write once and run on both platforms. They're common APIs. So that's essentially the convergence story, how we're not there yet, but we're on a path. And there are some common APIs, but they're not all there on both platforms. So next up is how we actually share code with MVVM. And before we get to that, we have to define what is MVVM. So MVVM is the model view model pattern that was created by John Gosman back when WPF was first introduced. It relies on XAML-specific data binding features and is really a derivation of MVC, model view control, that you might or you probably have heard of before. It's an architectural pattern that helps you structure your code, and it's really just about how you structure your code. There's nothing really more to it besides using that and some data binding. Now, the power of XAML's data binding is incredible. And there's actually there is a ton of information out there on how you use data binding, how you leverage it. I'm not going to cover that in this specific talk, but I encourage you, if you want to really get serious about MVVM, you need to look at that and really understand how data binding works. But you will see a few features, and I'll cover a few things in the samples I show you later on, but I won't cover it in too much detail. So before we kind of define the different parts of MVVM, the model, view, model, pattern, let's talk about why we want to use this. And essentially, we want to use this because it enables reusability. And it does that by loosely coupling the UI layer with your code or your app logic. So you can imagine a world where now you have a clean separation between your XAML and your front end and all your application logic in your modules and your C# and your assemblies. Also, if you can imagine working with a friend or working with someone else, a designer, you were able to basically work in parallel, one person on the UI stack and one person kind of coding the app logic, and both of you can work in parallel and then come together at the end and merge that together without breaking each other's code or basically being able to compile it. And of course, there's increased testability, which I won't cover here, but there's a lot of information on how MVVM helps you increase and make testable code. So let's get into defining each piece of the MVVM pattern. And before we do that, I want to show you my simple sample that kind of illustrates the MVVM pattern in a real world, well, not in a real world example, but in a simple example. So I'm going to switch to Visual Studio. And here I basically have a Windows Store application that is pulling down titles from Netflix. So what I'm doing is I'm making a request to the OData catalog that Netflix has, the OData API, and I'm pulling down a bunch of cover art or box art, what they call it, and displaying that on the screen. So you can see here I'm able to scroll through the application, list of movies, and they're basically pulling it down asynchronously, around 100 or 150 titles. And that's the application. So it's simple, but hopefully it kind of gets the point across when we go through the code. So let's close that down. And take a look at the structure of the application. So you'll see here that I have, under my solution, I've got 3 projects. I've got a model, I've got the view model, and I've got this thing called W8, which is actually just the view. So since we're talking about the model first, if we think of it as a layer cake, let's start with the bottom. We're going to talk about the model. So the model is a representation of the data. And essentially here, since I'm pulling down box art or titles that contain box art from Netflix, I've defined that structure in my project here, in my model. So you can see I've got a class that I've basically has some attributes on, data contract and data members. And they're defining some properties. And these are the same properties I get back from my OData call when I make a request to Netflix. So it's the JSON data that I get back. Now the title has an ID, a name, it has a rating, and a release year, but it also has something called box art. And so I've actually made another class for box art because that contains additional properties. So I've got something called a small URL, the large URL, basically all the links to actually the actual image itself. Now, if we jump back to the actual project itself, we've got something called a response wrapper, which we can ignore for right now. It's just an easy way to access the data that comes back from the JSON API. And that's the model. So let's go back to the slides. So again, your model can be anything. It can be the database. It can be from a web service, from a file system. What I've done is basically create a couple classes to show the structure of that data and what I'm pulling back from the Netflix API. So next up, we have a view model. And the view model is a specialization of the model that the view uses. So you can think of it as the glue in between the model and the view model, and the view. So when I say specialization, what do I mean by that? Well, I'll show you in the code in a second. But the important part of the view model is that it contains no UI code. It's just the plumbing in between the model and the view. It really informs the view how to update. And it's using that data binding magic that I won't get into too much, but I'll show you a little bit of the code. So let's switch back to Visual Studio. So here you can see my project, the view model project. And under there, I've got this class called title view model. And essentially what this class is doing is defining an observable collection, and that's some of that data binding magic, where it's basically a collection that is hooked up to the view so it knows when to update. So if I add something to the observable collection, the view will see that and it will update. So in my constructor, I'm calling a method called getTitles, and that goes and issues a query, and that's just a helper that I've created that does all the networking code that I won't go through right now, but we'll see that a little bit later. And then it calls the method loadTitles, and essentially just throws those titles into my observable collection, and but it's not throwing in the model, it's actually throwing in something called a new title art. So let's take a look at title art. Well, title art is just a simple class that defines one property, a string, and that's box art. And this is where I'm talking about the specialization of the view. Because if we look at the project itself, under references, I am referencing the model, but I'm not actually using that model when I'm passing it to the view. I'm passing it a list of title art. But title art is getting its information from the model. So that's where I've specialized that model. And that's all there is to the view model. Again, there's no UI code here. It's just some plumbing. So let's switch back to the slides. So the view. Well, the view, you guys have probably guessed by now, this is all the UI, user interface code that we have. But the goal of the view in MVVM is to have no code. You'll need to have a small bit of code to hook up the view model to the view, but really we don't want anything else in our view. So in your application, you may have multiple pages. Mine's pretty simple, it only has one. So I've got one view and one view model. You may have multiple pages to your application, so you could have multiple view models, and obviously different pages to represent the different pieces of your app. So if we go back to the code, we'll see here that in the Windows 8 project, which is actually my view, I've got my main page. And under my main page, I've got some scaffolding, basically. But then I've got this grid view. And that's what I'm using to show all the titles and all the box art. So the grid view is using, again, some of that data binding. I'm defining the item source, and I'm binding to a property called titles. Or that's actually the list. We'll see in a second. That's the collection called titles. And then I've defined an item template. And the item template is just simply an image. And the source is going to the box art. So let's look at the actual code behind. You'll see here that all I've done is created a new title view model. And I've set that to the data context, which basically means that I've told the view that, hey, this is where you're going to get the data from to show in the controls. And really, that's just one line of code. And that's all you should need in the ideal case when you hook up your view model to your view. Now, you saw that we were binding to something called titles. And then we were kind of showing this box art as the image source. So where's that coming from? Well, if we take a look at the title view model, you'll see that I'm actually have this public property in my observable collection called titles. And each title has a property called box art. So I'm actually being able to dot notate down into the collection and display different pieces via the controls. And that's really the power of the XAML data binding stack. So that's MVVM, and I'll switch back to the slides. And so you can kind of see how MVVM would help you reuse code. If I had, let's say I was building an application for Netflix and also Blockbusters, and they kind of had the same API that I was using, I was able to reuse that query code, reuse the model, reuse all that good stuff, and really just change the view, because that's what really the user sees and what needs to change from their perspective. Different branding, different images. But the view model and the view model and the model, I'm able to reuse that. But that's great if I was building two Windows 8 applications, store applications. How do I do this if I'm building this to the phone? I want to port this code to the phone. I just told you earlier that with the API Convergence, every API that's on Windows 8 is not necessarily available on the Windows Phone. So how do I get code to compile cross-platform? And that's where we talk about PCLs. So PCLs are portable class libraries. And they basically allow you to create an assembly of code that can run on either platform, Windows 8 or Windows Phone. Now in the image you see here, I've selected in this image Windows 8 and .NET for Windows Store apps, but I also have the option to pick Xbox or Silverlight or other .NET frameworks. So really, PCL is not just for porting code between Windows 8 and Windows Phone. It's about being able to reuse code across multiple platforms. So again, in this case, I've only used Windows 8 and Windows Phone, so it's going to actually restrict me to a subset of APIs that are available on both platforms. And the cool thing about our tooling is that when I'm actually coding this, IntelliSense will stop me from using APIs that aren't available on both platforms. So that's PCL. So now we have to kind of bring it all together. We need to be able to use MVVM and PCL together to create code that is portable and reusable across platforms. So before we get into another example that kind of shows all the pieces to this, I want to give you a high-level diagram of what we're trying to achieve. Essentially, we're going to have two apps, a Windows Store app, which you can see on the left, and a Windows Phone app, which is on the right. They're both going to leverage a portable class library that contains the model and view model. Because again, that's the stuff that's common to both applications, or both apps. Now, I mentioned that not every API is available on both platforms. So what happens when we run into the case when an API is not available on Windows Phone, but it is on Windows 8? And a great example of this is how you make basically how you do a networking request. So in Windows 8, you use a new API called the HTTP client, and on Windows Phone, you use the the web request. And so these are two different APIs that we have to use to be able to request data from Netflix. So what do? Well, this is where we have to start using interfaces and platform abstractions. Now, it's not as scary as it sounds. It's really straightforward. What you're doing is abstracting the concept of a network request and then implementing it concretely in both apps in a platform-specific way. So that's a lot to kind of take in, but let's see that in a real world. Let's see that in the example, and it'll be a little bit easier to kind of grasp. So let's go back to the code now. And before I show you the code, I want to kind of prove to you that this app does run on Windows Phone. So fingers crossed, we're going to see a very similar application show up on the phone here. And there it is. So again, now we're kind of scrolling vertically, but essentially we have the same application. The only thing that's changed is the view. And we'll see the code of this, and you'll see that I'm actually reusing the model in the view model. So let's start with the model. If you see here, again, I've got that box art and that title. Nothing's changed there. That's all the same. Now I've got the view model, which has changed slightly. There's a couple more things going on in this project. And the important thing is to note that the actual view model itself is essentially the same. I still have that observable collection called titles. I have my constructor that's still calling something called getTitles. And getTitles is still loading up those titles and putting it into my collection. But this is where things get a little bit different. Because as I mentioned, on Windows 8, I'm using the HTTP client API. And on Windows Phone, I'm using a different API. So how do we get around that problem? Well, as I mentioned, it's about using interfaces. So let's look at this interface called the iGetTitle service. Essentially, all this interface is defining is a method that accepts a callback. And so this callback is basically a list of titles. It's going to take a list of titles. And I'll show you how we invoke that a little bit later on. So what I've done is I've said, hey, how you get titles is not important to the view model. What's important is that you define a contract so the view model can get those titles. And if we go back to our view model, you'll see that when I create my view model, I actually pass in an iGetTitle service. So this is going to be a concrete implementation of the iGetTitle service that is platform specific. And I'll show you that in a second. Once I have that getTitle service, I can just simply call getTitles, which I have defined here. And that accepts a callback, and that callback is then raised. So if we go into the Windows 8 application, you'll see that when I create the view model, the first thing I've done is I've passed in a new query. So let's take a look at query. What's query? Well, query is that concrete implementation of iGetTitleService. And you see here that I'm basically using the HTTP client API that I talked about that's available through the Windows runtime for Windows 8. And I'm doing basically just making a quick request to the Netflix API, and you can see the call up here. I'm just hitting the OData catalog, and I'm requesting a bunch of titles. I'm then doing some deserialization because I'm putting all that JSON into my model structure, so I have that represented in my application. So that's what I'm doing for Windows 8, but what about for Windows Phone 8? So again, if we dive into the view for Windows Phone 8, we'll see that I'm still creating the title view model, and I'm still passing in a query, but now if I look into that one, it's actually under a different namespace. It's under the phone service, and I'll show you that in a second, how I've kind of structured my project. But this implementation is using the HTTP web request API, and that's what's available on Windows Phone 8 to make your web requests. So again, I've got two different implementations of the iGetTitle service, and in my views, I'm passing one or the other to the view model. The view model doesn't care on the actual concrete implementation. All it cares is that the implementation implements this interface, and that's exactly what we've done. So if we look at our project structure again, you'll see here that I have the model, and I have the view model, and I've shown you the Windows 8 view and the Windows Phone view, but we've got these two other projects, a phone service and a store app service. So if I look at the store app service, this is the Windows 8 service. And you'll see here that I've got the class query, and that's what I showed you earlier. It's implementing the iGetTitle service. And if we look at the phone service, you'll see it's something very similar. I've got a query, but again, that's implementing iGetTitle service, but it's doing it in the phone-specific way. And that's really all there is to it, to the abstraction pattern, and using MVVM and PCL. But there are a few other caveats that we have to kind of pay attention to. So if you were observant, you saw in my view model, I'll bring it up here, that when I created the view model, I was passing an iGetTitle service, but I was also passing something called iDispatcher. And so, we talked about API convergence and how there is a difference. There's also some differences in the actual platform itself. So for example, in Windows 8 store apps, you actually use the platform takes care of marshalling calls from the UI thread to a background thread. You don't have to worry about that if it's happening asynchronously. In Windows Phone, the responsibility falls to you as a developer. Now, it's not hard. All you have to do is kind of get an instance of the dispatcher and basically invoke a call on it. And that's kind of what I've done here, is I've used the exact same pattern of abstracting the concept of a dispatcher. So I've defined something called iDispatcher, as you can see here. And basically, again, defining a method saying dispatch, and I'm going to pass it in an action. So when I go back to the Windows 8 application, since Windows 8 handles marshalling the calls for me, I'm just passing null. There's no problems. In Windows Phone 8, because I have to handle that myself, I'm actually going to pass in a new phone dispatcher, and that's just taking a reference to the current dispatcher. So again, I've abstracted the concept of a dispatcher, and I'm just going to pass in the actual concrete dispatcher to it. So in the view model, again, it doesn't care. All it cares about is me passing in an iDispatch reference. And in the Windows 8 case, it's null, but in Windows Phone, it's actually something concrete. So let me bring that up again. And you can see that here. Now there's one other trick to this. I didn't want to create two view models. I want one view model that I can reuse, I can put in the PCL, and it can be used on Windows 8 applications and Windows Phone 8 applications. So what do we have to do here? Well, there's a problem, right? Because I'm passing in a dispatcher for the Windows Phone, but null for Windows 8. That may throw an exception if I don't do some platform-specific checks. And that's where you see this conditional compilation flag. So again, this may not be the best way to architect it. I've kind of done this to force the example. But essentially what I've done here is I've said, when I go to load titles, because the phone needs to have a concrete implementation of iDispatch, which again is how I abstracted the dispatcher, I basically just ifed it and said, hey, if this is Windows Phone, and Windows Phone is actually a build time flag that I've created, then go ahead and invoke the dispatcher and go and load my titles. If it's Windows 8, then just don't worry about that. Just go ahead and load the titles because the platform takes care of it. And essentially, that's all there is to getting code to run on both Windows 8 and Windows Phone and sharing the view model and the model. So let's go back to the slides. Okay, so we've talked about sharing the model and the view model using the MVVM pattern and the PCL, but we haven't talked about sharing the UI. And really the message here is that you shouldn't spend too much time on trying to share your UI code across platforms. And there's a good reason. You want your application to take advantage of the form factor. A Windows 8 app looks a lot different than a Windows Phone app. And you saw that in the Huffington Post example. Scrolling horizontally versus scrolling vertically, the amount of real estate you have, being able to take advantage of the charms in Windows 8 and that aren't available in Windows Phone, different orientations. So there is some complications there when you try and share UI code. Now that's not to say that you can't share your UI code. The goal there, really the message is not to spend too much time on it and take advantage of the form factor. So when you're defining things like item templates, as you saw in the grid view that I showed you for the Windows 8 application, that's using core controls like stack panels and canvases and buttons and checkboxes. They're available on both platforms, so you can reuse those. But there are new controls like the grid view in Windows 8 that aren't available in Windows Phone. So you need to pay attention to what is reusable and what isn't reusable, and really make your investment more on sharing the view model and the model. So let's take a quick recap of what we've kind of covered today. What to share and how to share. So again, the view should really be platform specific. Take advantage of the device. Take advantage of the form factor. Now the view data binds to the view model. The view model is a specialization of the model, and that references the model. So we've got that portable and common code in the view model and the model. Now there's one thing I haven't mentioned, and that's portable versus common. There is a difference. So portable code is code that can be compiled on any platform and run on any platform. That's what a PCL is. A portable class library can be compiled on Windows 8 and run on Windows Phone or vice versa. Common code has to be compiled on a specific platform. It can be shared, but it needs to be compiled on the platform it's going to run on. So what does that mean to you? Well, when we're creating a PCL, you want to stay away from using any Windows runtime APIs or any Windows Phone runtime APIs. And if you saw in my samples, I was really just using the .NET APIs, core types, basic types. Those are available on both platforms. So my portable class library has just got this code that isn't using any of the runtime APIs. Now that's not to say you can't share that runtime API code. If you remember back to the API Convergence, we keep coming back to it, but if you remember that Venn diagram in the intersect, there were some APIs that are common to both Windows runtime and the Windows Phone runtime. That's the code that you want to have common. So to be able to share that code between your two applications, what you want to do is basically create one project that contains your common code and just link to it in each of your projects. And that's how you basically share code and portable code portable code and common code across both Windows 8 and Windows Phone. And with that, I hope you've learned how to kind of share your code. If you have any questions, feel free to ask them. And I think we're taking a quick break right now. We'll be right back.